Previously, you have learned that the limit of a function can be determined in two ways. One, construct a tables and study the behavior of a function values x approaches its indicated value, or it sketch the graph of the function and study the behavior of the function as it goes closer to the given value of x from both directions. But this method of the function can be time-consuming and tedious. Nevertheless, following certain rules on the limits can help simply this process. So now, let's talk about limit theorem. So we will have 9 theorems that we will be discussing. But before that, let us first define what is the meaning of theorem. A theorem is a proposition or a statement in math that can be proved and has already been proven true. Now, let's define what is the limit theorem. So let C and K be real numbers so that the limit of f of x as x approaches C and the limit of g of x as x approaches C exists. So these are the 9 theorems. So we have constant theorem, identity theorem, constant multiple theorem, sum or addition theorem, difference or subtraction theorem, product or multiplication theorem, quotient or division theorem, power theorem, and lastly, root or radical theorem. So let's talk them one by one. First, we have constant theorem. So this theorem states that the limit of a constant is itself. If k is any constant, then the limit of k as x approaches c is equal to k. To understand more, let's have an example. So we have the limit of 5 as x approaches to 4. Since the value of k or our constant is k, which is 5. So therefore, the answer will be 5. Another example, we have the limit of 11.99 as x approaches to 9. Since our k is 11.99, therefore, the answer will be 11.99. Another example, we have the limit of 3/4 as x approaches 6. Since our k or the value of k will be 3/4, so therefore, the answer will be 3/4. Next example, we have the limit of 105 as x approaches to 7. Since the value of k is 105, so therefore, the answer will be 105. And last example, we have the limit of 10 as x approaches to 1, since the value of k will be 10, so therefore the answer will be 10. So that's all about the constant theorem. The next theorem is identity theorem. So this theorem states that the limit of x as x approaches c is equal to c. This may be thought of as the substitution law because x is simply substituted by c. In other words, we are going to substitute the value of c into the variable x. So applying this theorem, we have the limit of x as x approaches c is equal to c. To understand more, let's have an example. We have the limit of x as x approaches 12. Since the value of c here is 12, so therefore the answer will be 12. Another example, we have the limit of x as x approaches 25. Since the value of c is 25, so therefore if you are going to substitute 25 into the variable x, so therefore the answer will be 25. Another example, we have the limit of x as x approaches to 3/4. Since the value of c is 3/4, so therefore the answer will be 3/4. Next example, we have the limit of x as x approaches to 110.10. Since the value of c will be 110.10, therefore the answer will be 110.10. And last example, we have the limit of x as x approaches 10. Since the value of c is 10, if you are going to substitute that one into the variable x, the answer will be 110. The third theorem is constant multiple theorem. This says that the limit of a multiple of a function is simply that multiple of the limit of the function. Suppose we have the limit of f of x as x approaches c is equal to L. Then we have the limit of k multiplied by f of x as x approaches c is equal to k multiplied by L. So applying this theorem, we have limit of 3x as x approaches 3. Since as you can see, our k here will be 3. So we have 3 multiplied by the limit of f of x, which is x, and then approaches to 3. So we need to bring down 3, and then since this will be identity theorem, wherein we need to substitute the value of c into the variable x, so we have 3. So now, 3 times 3 is equal to 9. So our final answer will be 9. Another example, we have the limit of 1/4 x as x approaches to 1. Since our k here is 1/4, and then multiplied by the limit of f of x, which is x, as x approaches to 1. Again, we need to bring down 1/4 and then multiplied by the limit of x as x approaches to 1. Since the value of c here is 1, since this will be an example of identity theorem, so we need to substitute c into the variable x. So we have 1. So now we have 1/4 times 1. So our answer will be 1/4. The fourth theorem is the sum theorem. The limit of a sum of a function of the limit of the individual function. Suppose we have the limit of f of x as x approaches c is equal to L, and the limit of g of x as x approaches c is equal to m. So therefore, we have the limit of f of x plus the limit of g of x as x approaches c is equal to L plus m. So to understand more, let's have an example. So we have the limit of 3x plus 2 as x approaches to 2. Since, as you can see here, so we need to distribute each term yung ating limit of x approaches to 2. So now we have limit of 3x as x approaches to 2 plus limit of 2 as x approaches to 2. Since as you can see here, we have constant multiple theorem, so now we have 3 multiplied by the limit of x as x approaches to 2, and then we have the limit of 2 as x approaches to 2. Now, here, we need to bring down 3. And then since the value of c here is 2, so we need to substitute into the variable x. So we have 2 and then plus. Since we have identity theorem here, wherein our constant is 2, so we have 2. So applying the order of operation, so we have 3 times 2, which is 6 plus 2. So therefore, the final answer will be 8. Another example, we have the limit of x plus 7 as x approaches to negative 1. So again, we need to distribute the limit of x approaches to negative 1 in each term. So we have the limit of x as x approaches to negative 1 plus limit of 7 as x approaches to negative 1. Since we have identity theorem here, so we need to substitute the value of c into the variable x. So therefore, we have negative 1 plus, here, since this will be a constant theorem, so we're in the value of k, or our constant is 7, so we have 7. So we have negative 1 plus 7, our final answer will be 6. The next theorem will be difference theorem. So the difference function of is the difference of their limit. So suppose we have the limit of f of x as x approaches c is equal to L, and the limit of g of x as x approaches c is equal to m. So therefore, we have the limit of f of x minus the limit of g of x as x approaches c is equal to limit or L minus m. So now applying this theorem, so we have limit of x minus 2 as x approaches to 1. So now we need to distribute the limit of x approaches to 1 in each term. So it becomes limit of x as x approaches to 1 subtract by the limit of 2 as x approaches to 1. Since we have identity theorem here, so we need to substitute the value of c into the variable x. Since our c here is 1, and then if you are going to subtract by the limit of 2 as x approaches to 1, since this will be a constant theorem, so the value of k is 2. So we have 1 minus 2. So therefore, the final answer will be negative 1. Another example, we have the limit of 5x minus 1 as x approaches to 2. Again, we need to distribute the limit of x as x approaches to 2 in each term. So it becomes limit of 5x as x approaches to 2 subtract by limit of 1 as x approaches to 2. Again, since this will be an example of constant multiple theorem wherein the k will be 5 multiplied by the limit of f of x, which is our f of x is x, as x approaches to 2 minus the limit of 1 as x approaches to 2. So we need to bring down 5 multiplied by the limit of x as x approaches to 2. Since this will be an example of identity theorem, so we need to substitute the value of c, which is 2. And we have a constant here, which is the value of k is 1. So we have minus 1. So applying the order of operation, so we have 5 times 2 is 10 minus 1. So the final answer will be 9. The next theorem is product theorem. The limit of a product of function is equal to the product of their limit. Suppose we have the limit of f of x as x approaches c is equal to L, and the limit of g of x as x approaches c is equal to m. Then we have the limit of f of x multiplied by the g of x as x approaches c. Then therefore, we have the limit of f of x multiplied by the g of x as x approaches c is equal to L multiplied by m. So applying this theorem, we have the limit of x multiplied by 2x minus 1 as x approaches to 1. So here we need to distribute limit of x as x approaches to 1 in each term. So it becomes limit of x as x approaches to 1 multiplied by limit of 2x as x approaches to 1 subtract by limit of 1 as x approaches to 1. So again, since this will be identity theorem, so we need to substitute. So it becomes 1 multiplied by, since this will be a constant multiple theorem wherein ours k will be 2. So we have 2 multiplied by the f of x, which is x, as x approaches to 1, subtract by the limit of 1 as x approaches to 1. Next, we have bring down 1 multiplied by, 2 multiplied by the limit of x as x approaches to 1. Since this will be identity theorem, the value of c is 1. So we have 1 minus, since this will be a constant theorem. So our constant or k here is 1. So we have 1. Then bring down 1 multiplied by, applying the order of operation, 2 times 1 is 2. And then minus 1. So we have 1 multiplied by 2 minus 1 is 1. So therefore, the final answer will be 1. Another example, we have the limit of 3 multiplied by 2x minus 1 as x approaches to 1. So again, we need to distribute the limit of x as x approaches to 1 in each term. So it becomes limit of 3 as x approaches to 1 multiplied by limit of 2x as x approaches to 1 minus limit of 1 as x approaches to 1. So therefore, since this will be constant theorem, so it becomes 3 multiplied by, this will be a constant multiple theorem. So we have 2 multiplied by the limit of x as x approaches to 1 minus limit of 1 as x approaches to 1. So bring down 3 multiplied by 2. And then since this will be the limit of x as x approaches to 1 is an example of identity. So we have 1 minus 1. Then it becomes 3 multiplied by, applying the order of operation, 2 times 1 is 2 minus 1. So we have 1. So therefore, 3 times 1, the final answer will be 3. The next theorem is quotient theorem. So the limit of a quotient of a function is equal to the quotient of the limit of the individual function, provided that the denominator limits is not equal to 0. Suppose we have the limit of f of x as x approaches c is equal to L, and we have the limit of g of x as x approaches c is equal to m. Then we have the limit of f of x over g of x as x approaches c is equal to the limit of f of x as x approaches c over the limit of g of x as x approaches c is equal to L over m, where m is equal to or is not equal to 0. Why? Because if we are going to get 0 on the denominator, so the answer, the limit does not exist or undefined. So again, so let's say for example, we have the answer of 4 over 0. So meaning to say, the answer will be undefined. And then how about 0 over 0? So if we are going to get the answer 0 over 0, the answer will be indeterminate. And let's say, for example, we have 0 over 4. So now, the final answer will be 0. So that is the difference of, or the difference between the three. So now applying the theorem, so we have the limit of x over 5 as x approaches to 2. So again, we need to distribute limit of x approaches to 2, both numerator and then denominator. So it becomes limit of x as x approaches to 2 over limit of 5 as x approaches to 2. Since, as you can see here, this will be an example of identity theorem. So we need to substitute the value of c into the variable x. So it becomes 2. And then the limit of 5 as x approaches 2 is an example of constant theorem wherein the value of k is 5. So therefore, we have 5. So this will be our final answer. We have 2 over 5 or 2/5. Okay, next we have the limit of x plus 2 over 5 as x approaches to 2. Again, we need to distribute yung ating limit of x as x approaches to in each term. So it becomes limit of x as x approaches to 2 plus limit of 2 as x approaches to 2 over the limit of 5 as x approaches to 2. So since this will be an example of identity theorem, so we have 2 plus, and then the limit of 2 as x approaches 2 is an example of a constant wherein the value of k is 2. So we have 2 over, also the denominator is a constant theorem, so we have 5. So our final answer, we have 2 plus 2 is 4 over 5, or the final answer will be 4/5. The next theorem is power theorem. This theorem states that the limit of an integer's power p of a function is just the power of the limit of the function. So if the limit of f of x as x approaches c is equal to L, then we have the limit of f of x raised to p as x approaches c is equal to the limit of f of x raised to p as x approaches to c. So applying this theorem, let's say for example, we have the limit of x to the fourth power as x approaches to 2. Since as you can see, our exponent will be 4. So now we have the limit of x raised to the fourth power as x approaches to 2. So again, we need to substitute the value of c into the variable x. So it becomes limit of 2 raised to 4 as x approaches to 2. So it becomes, if you want to expound this one, 2 raised to 4. So the answer will be 2 times 2 times 2 times 2, or is equal to 16. So next, we have the limit of x squared minus 2x plus 1 as x approaches to 3. So here, as you can see, we have 3 terms. So we need to distribute the limit of x approaches to 3 in each term. So it becomes limit of x squared as x approaches to 3 minus limit of 2x as x approaches to 3 plus limit of 1 as x approaches to 3. Since this will be a power theorem, so again, we need to substitute the value of c into the variable x. So it becomes limit of 3 square as x approaches to 3. Next, we have, this will be a constant multiple theorem. So our k will be 2 multiplied by the limit of x as x approaches to 3 plus the limit of 1 as x approaches to 3. Now, the limit of 3 square as x approaches to 3 becomes 9. And then we have 2 multiplied by the limit. So it becomes 2 multiplied by this one. So we have x as x approaches to 3. It becomes 3 plus the limit of 1 as x approaches to 1 is 3. Since as you can see here, this will be a constant theorem. So our k is 1, so we have 1. So applying the order of operation, so we need to perform first 2 times 3. So we need to bring down c 9. 9 minus 2 multiplied by 3 is 6 plus 1. So now we have 9 minus 6 is 3 plus 1. So the final answer will be 4. Okay, the last theorem will be the radical or root theorem. So this theorem states that if n is a positive integer, the limit of the nth root of a function is just the nth root of the limit of the function, provided that the nth root of the limit is a real number. Thus, it is important to keep in mind that if n is even, the limit of a function must be positive. If the limit of f of x as x approaches c is equal to L, then this will be the outcome. So to understand more, let's make it easy. So it becomes limit of square root of x as x approaches c, or is equal to the square root of the limit of x as x approaches to c. So applying the theorem, so let's say for example, we have limit of square root of x as x approaches to 9. Since the value of C here is 9. Okay, we need to substitute the value of C into the variable x. So it becomes limit of square root of 9 as x approaches to 9. Since 9 is a perfect square, therefore, the final answer will be 3. Next example, we have the limit of square root of 3x minus 5 as x approaches to 7. Here, we need to distribute the limit of x as x approaches to 7 in each term inside the roots or the radical sign. So it becomes limit of or square root of square root of a limit of 3x as x approaches to 7 minus the limit of 5 as x approaches to 7. Since this will be a constant multiple, so therefore it becomes the square root of 3 multiplied by the f of x, which is the limit of x as x approaches to 7, minus the limit of 5 as x approaches to 7. Here, we need to bring down 3, so it becomes square root of 3 multiplied by the limit of x as x approaches to 7. Since this will be identity theorem, so we need to substitute the value of c into the variable x, so it becomes 7 minus the limit of 5 as x approaches to 7 is a constant theorem, so it becomes 5. So applying the order of operations, so it becomes square root of 3 multiplied by 7 is 21. Okay, 21 minus 5. So therefore, we have the square root of 16. So therefore, since 16 is a perfect square, the final answer will be 4. Okay, that's all about the radical or root theorem. Okay, that's all about the limit theorem. I hope you really understand our discussion. So thank you.